Okay, let's do the level Spycy now. I asked you to find a mean, median, mode, and standard deviation for each distribution. Now I showed you that you can just copy these. So basically, STDs is equal to this. All right, it's going to give you like a list, and then your STD. Oh, sorry, STDs. But it's you can just say it's a list, right? You can have them like that. That's one of ways to do it. You can write a function, and I wanted you to write a function that just outputs all of this together, because the pandas that do not give you they don't give you the median, for example. So what you can do is write a function that does this, right? So you need to loop over the columns in your data sets. I am going to directly write a function, so your function is going to be called, let's say, get descriptive stats. Let's leave the arguments for now. We're not going to need our data for sure, right? So we need to loop over the things, and we need to append to we need to store that. So the best way, for example, for the standard deviations, you first create an empty list, and they say for I in columns. So because this is how we for I in columns, this is how we separated data. We're looping over the headers, right, over column names. So this is going to be the other argument for I in columns. So your stds dot append, you append to this empty list. And then the way you do the standard deviations, you can do it from numpy. It's just numpy std of your data set, right, of your data. And then you're looping over your column names, because this is a pandas data frame, so it works like this. You're doing data pdf1, pdf2, pdf3, and so on, right? Then you can do the same for means. So means is equal to an empty list. Then you can say medians is equal to an empty list. And then your modes equal to an empty list. Empty list. And then you can append to means list dot append, and then in numpy mean of your data over the columns, column names, and then your medians append to a list, to empty list of medians. NumPy also has a median. I think I made a mistake here. This has to be in yes, exactly. And then median of your, this is not good. This is, I made a mistake here, sorry. Median of your data over I. Now you know how median and mean are in for Gaussians, but I will let you discover that if you don't already know. And then your modes you append to this empty list. And now NumPy doesn't have, but stats from SciPy, they do have. So the mode you can calculate from SciPy. It should be something like, let's import the stats from a SciPy library. We can say here, we go back to the import part. So you say import, from SciPy import stats, run that. And then we go to the Spycy level modes append. So that is going to, excuse me, be stats dot mode, or you can look it up. You can Google how to do the what is the function. You can do SciPy stats, and then it will give you all of the functions that you can do. Let's do under the Well, you can find it yourself. But in any case, going back to this, so starts mode of a data index I, right? This is what we're going to append, then return in one indentation to the left, and then you say return stds means, medians, and modes. Run that, and then in another cell we open another cell and just say stds means, medians, and modes is equal to get descriptive. You can just do tab and it will finish it for you. Yes, pressing tab. Get descriptive stats, and then you need your data and columns, which is called the same way as we defined those things already, so they have the same name, but you have to be careful if you if your columns are called like calls or something, and data is called like df or whatever you want to call it. But yeah, you can run this, and now you can say stds, run it, and there you have a list of your stds. You have the list of medians, for example, and so on. So now you can work with that. What you also need to do every time is you need to include a docstring in your function. So this is 3 quotation marks times 2, so 6 quotation marks, and you have to write something like this is a wrapper function, right? It's a wrapper function because it's you're just using the existing functions from NumPy and SciPy, but it's a wrapper function to get the descriptive statistics of a given PDF. What else can we do? We can say that actually what is really important is that the way the data set where we're working with is a pandas data frame. So you have to emphasize that this function is designed to work with a pandas data frame. And then you need to say your arguments. Your args are so your data, and then you have columns. So your data is the PDF, so distribution as a pandas data frame, or you can say you can put a data type here, pandas data frame, immediately, so you don't have to write it here. And then columns are we had them as string list, right? It was a string list, and this is a column names, and then what it returns what? Let's put a tab just to make it look better. stds is going to return a list, right? So list of standard deviation values, and then it's going to return your means also as a list. We have an extra here list, mean values of distribution, medians, and so on. You can write all docstring, right? And then you run that, and then, for example, if you need help, if you don't know, you forgot what are the arguments of your function and what is the output, you just call help, and you call your function get descriptive. Let's finish it, and then you run it, and it spits out your docstring. So you should always do that in case you need help. So we did this. We did the Spycy level. You can also print it, right? You can say print. Of course, always use the F string, so F or quotation marks, and then you say these are my standard deviations, and then you open curly brackets and then you put your variable there, and our variable which we want to load here are the STDs, right? And then it says these are my standard deviations. It gives you a list there. Okay, so that is it, right? I think that we don't need to do anything else here. Okay, I'll stop recording now and then see you all soon.